Hi everybody, my name is Alex Palesandro and today we will talk about Docker. This is the second video of the second lab of the cloud computing course. In the first video we saw how we can, using the Linux kernel, create applications which are constrained in terms of access to the system, in terms of resource they can consume, and those applications can be containerized in a sense. This concept can be generalized, and here we have Docker, because Docker can allow us to run applications which are containerized and we can simply download from the internet, from repository, and then run. Or we can package our application and put them on remote repositories and then run them on another host. So the main idea is that all those container images that we use contains everything we need to run the application. Okay, so when we refer to Docker in those videos, we are referring to Docker Container Engine, which is the main component of Docker ecosystem. Docker Corporation is a company, has plenty of products. We will refer just to the Docker Engine, which is, I think, the most popular container engine that you have today. So let's start with a simple hello world. So Docker run hello world. Nice. We can type the same with Docker container run. So in the lab you will find this syntax, but it's the same without container. You can also define new an alias in order to type less, so you can do simply Docker run hello world, and then you can type more or less, which is always a good thing. Okay, so what we can use for as a first image is to, I think we should follow the lab. So for example, we can easily show that with Docker PS we can see that there are no container running. With Docker ls, I think it's image ls, we can show which images have been downloaded. Plenty of different stuff, it's nice. An important point here when you are doing the lab is to do not forget to adjust the MTU. So we have a specific section that tells you how to do that. I will repeat it. So we have to modify, to create a file which is docker daemon JSON. I use Vim, you can use any editor you want. Vim, I think it's the best, but yeah, it's my opinion. And then you have to write MTU like that, so we have to limit it. And then we have to restart. So let's restart Docker with the systemctl restart. We have to be root for that. Nice. And then all the containers that we will create will have the correct MTU, and we are able to talk to the internet. So let's start, for example, a Ubuntu container. So image, no, we have not to say image, we have to specify the name, Ubuntu, and then we can use the Ubuntu, and then we say, okay, let's start from a Vim bash. And we are in. And then we can, for example, make a apt update. Nice, it works. And then we can install, I don't know, curl. Yeah, okay. It downloads it, unpack it. We have a system inside. We can simply run our application in a Ubuntu container. Pretty simple. You can do tests and so on. It's nice. We can, I don't know if you have ping. But if we want to care, for example, Google, it works. So we have the Google page. So it's a container, we can exit from it, and then, as you can say, the container has stopped because we decided to run it with bin bash. But for example, if we run an Nginx, so we have the Nginx which is run, and we have the Nginx run here. So it's easy, we have a web server, no configuration at all, and it's running. If you want to run a container in background, we have simply to put a -d, I think here, maybe minus, like that, so the container is running in background and it's still there. It's hard to follow this, so I think it's easier to, we have this container running, created 4 seconds ago, up from 3 seconds, and it is exposed, it exposed the port 80. This is the name, and if I want to stop it, I have to use, for example, the name, I think. No more, and then if I want to remove it, I have to remove it like that. So this is easy. I downloaded an Nginx, I put it in running, and it's gone. So we have to configure it obviously if you want to do something useful, but it's pretty easy to do so. What is also interesting to do is, I think, so then you are playing with Alpine Linux. Alpine Linux is it's a nice distribution because it's really small. So we have those small images that can be used to package our application. Let's have a look to this. So for example, let's do I think it's Docker pool. It's okay, yes, because before was Docker image pool, Docker pool, and I put okay Alpine Linux, Alpine. So as you can see, we have just one layer here, and we can easily see that the application is, I don't know, few meg, 8 meg. So 8 meg, it's really small. It's really small. It's easy, so it's faster to run, because when you want to run an application, we have to pull the application and then run it. And if we have such a small container, such a small base container, it's really nice because it's fast. And then so we have some exercises to assess the isolation of containers, to the fact that we have we can run a shell in a container which is in deadlock, and also some exercise about the Docker networking. I think the most interesting one, for example, is to run an HTTP server and then a complete LAMP application. So LAMP means Linux, Apache, MySQL, PHP application inside containers. So this is, I think, an example of how simple can be compared to simple installing this LAMP stack on a Linux system, for example, without Docker. How simple, how fast it is. Okay, so let's start this. I think it may be useful to do it and comment it. So we start this command with this command. So we're running the Docker Lab Apache image. -rm means that when we stop it, we want to remove it, if I remember correctly. -p will expose the port 80 of the container on port 8080 of the host, so it's easy for us to communicate to container part. And then we will download HTTPD, which is I think a synonym of the Apache web server, version 2.4/Alpine. So Alpine is the basic image that we will create. So it is unable to download the image, and what we see is here is interesting because we have to pull several layers that are from HTTPD, but since we already download before the Alpine image, we have already this image. So this union file system, it's nice because all our images are not really a single blob, but they are divided in different layers, and when we share layers between different images, we can only download what is missing, and so we have this incremental procedure where we can build the image. And this makes the download of images pretty fast because we can share common layers between different containers. Okay, so now we have downloaded our server, the server is running. And now let's move to the second part. Here we want to change the content of our Apache container. So what we are doing here, first of all, we do a docker exec. Docker exec means that we will execute a command inside the context of the container. So we already have a container running, we exec into it, bin.sh is the shell, and then we create a new main HTML file with hello world. It's done. Nice. It's done. And then what is interesting here is that if we curl the port 8080, we should see this hello world message, because we exposed the port of the container on that port on the host. So we are on the host, we are curling our local host on 8080, and we should see this this file. Sure, we have to install a curl on the host, which is not done so far. Let's wait that curl is properly installed. It requires some time, but yeah, we can move to the next point, I think. Yeah, okay, so we are done. Okay. And then we have our hello world. So so we are changed the basic container with a custom file, and we had the message that we want. So we expose the container to our host. So if we are, for example, on a web server, we can simply do that, and then our container is exposed to the internet. It can be consumed by everyone. Okay, it's not the best practice, but because when you want to have a real world virtual server, you want to have it persistent and tolerant to the failure of your system and so on and so far. But as an example, it's really useful. And yeah, you can do that on your Raspberry Pi, because for example, Docker is supported also on ARM architectures, and run the same example. And yeah, if you have a web server on your Raspberry Pi, you can do it the same we did in this VM. So what we can do here is also to create the, so here it proposes you the to create the database server. This is really interesting because it shows you how we can customize the images without touching the container itself. So as we mentioned before, in Docker we have an image which is a Docker image, and we should avoid to modify it with our data. So we have multiple ways to change the configuration of a container without having to modify the image. In this exercise 3.3.5, we can see how. So let's start by creating the directories it asks us for. Okay, let's do that. Yep. And then we will create a simple script that will initialize the database, so a table with Docker images, and then insert few records. It's really simple. Okay, we created those two files, and then we will try to run a MariaDB server, so a MySQL server with all the configuration and all the persistence that you can get in Docker. And this is quite interesting because we are running this Docker. Okay, it's MariaDB lab. We are using the Docker lab network. I'm not sure that we created the Docker lab network. So, yeah, we have a command here, so we can create this network. I think we will discuss it in the next video about network. So we still create the network, but yeah, this is interesting because you can resolve by name the other containers. So you have not to know which are the IPs of those containers. We simply use the network, and then if they are in the same network, we can just refer for example, from the HTTPD container to the DB, like Docker Lab MariaDB, without having to know the IP that can change and so on. So Docker Network allows us to create a DNS resolution domain for our containers. And if we create a custom network, we can also isolate the communication of those among the other containers. So, okay, let's move back to so we were to the creation of this container, which is pretty interesting. So as we mentioned, we had to create the network, which we did. And now we have plenty of interesting stuff. What we are doing here is to use two features which are really, really important in Docker. Sorry for that. So the first one is path configuration using environment variables. This is really, really useful and is really, really adopted in many contexts. I have an application with a complex configuration file. What I do is to say, okay, let's let people, so let user to configure it by simply passing environment variables. So for example, if I want to change the name of the database, I would set the MySQL database. If I want to change the root password, I simply pass the root password, and so on and so far, so for the user and for the other password. And this is something that is really interesting because I do not have to recompile my Docker, I just pass normal variables, and also I do not have to deal with the complex configuration, which can be on several files with plenty of default values. I don't want to touch them. And this approach is really used in a lot of containers that you can find on the internet. So I remember, for example, Grafana, the dashboard framework where you can create your dashboard to inspect your system, to plot your metrics. It works exactly in the same way. You have to pass with environment variable your configuration. And then, so this is the first point. The second point are volume. So you can say we will use specific volume which will persist the life of the container. So normally when you save a file in the container, this file is not persisted at all, and at the date of the container it will be erased as the rest of the container, because it is a non-persistent file, so it is not persistent storage. Here, if you define volume, you can say, okay, let's mount a certain path of my host inside the container. So I will mount this path that we created before has a certain path in the container. So I do that for the database, and I also do that for the scripts, which is interesting because is how we saved our scripts. And those scripts will be mounted here, Docker entry point initdb point D directory, which is where MySQL expects to see in its scripts, so scripts that will be executed at the start of the MySQL server. And another point is that this volume is mounted as read-only, so you are not supposed to be able to modify those scripts inside the container. This is not the case of database, where database needs to be modified because we are persisting our data, our records inside this container. Okay, so let's start it. Okay, what we forgot to we forgot the image because it was the last point, so we have to take, okay, MariaDB 10, so 10 is the version. MariaDB is I think a fork of MySQL, but it's pretty much the same application. So we already had plenty of layers, we downloading them, and then we are running it. So we have our DB running, we have our HTTP server, we have our MariaDB running. It's fair enough, and we can, I think, also see the logs of this container by simply do that. So we can see what it's doing. Even if we detached it, you can see that it started correctly, and it started also running the scripts that we mounted for it. Okay, so I don't know if you can get some other useful information. Yeah, it also kept our environment variables, so we saw the root password. And then I think, yeah, it says, okay, I'm listening and I'm ready to go. Okay, so I think that can wrap up for this video. In the next one, we can complete the creation of this topology, creating from scratch our HTTP server, I think, and adding our web pages there. And then we can show how we can simply define this topology by description, so in a declarative way, in order to make it easy to recreate them, to create those containers without having to retype all those commands that we have typed so far. So thank you for watching, and yeah, see you in the next video.